Welcome back, team. What is a virtualization? What is containerization? So these differences first we should understand. So what exactly the virtualization is referring? What exactly the containerization is referring? So these differences we should understand. See, what exactly the virtualization here, team? Just follow this one. For example, team, you know this one already. This is what exactly you are provisioning your components also today. Underlying hardware is there. On top of it, underlying hardware in the sense networking, storage, CPU and RAM. On top of it, you are installing the host operating system. On top of it, you have the hypervisor. The hypervisor is completely responsible to split the hardware infrastructure into different machines. Different machines. Best example, if you ask me, your virtual machine is the best example for this. Team, in Azure Cloud, when you are provisioning a virtual machine, right, usually you are selecting some BTS, a B3S, a B4S, right, or BTMS. These are all the series you are seeing. That is what they already split this particular hardware into different hardware items. Okay, different machine types. On top of it, you are selecting an Ubuntu machine, right? That's what exactly you're doing. When you selecting the Ubuntu operating system or Windows operating system or CentOS operating system, that one will be installed on that machine and that machine will be ready for you. That's exactly the same thing what you are doing in virtualization, right? Same thing, team. That's what exactly you are provisioning your virtual machine also. I believe the concept is very clear. If you go to your virtual machine, because you're already going through a lot of times on the virtual machine, right? So that's why you know this one very well. You just go there. I'm just showing the case whatever I discussed. Okay. Just click on the create button. Sorry, team. Click on the create button. So once you click on the create button, there exactly I'm talking about this one, team. Okay. I'm exactly talking about this one. For example, if you see something in this particular virtual machine section, just a second, it is taking some time for me to load. Alright, so now I'm talking about this one here. You are selecting an operating system with the image Ubuntu or Linux or CentOS or whatever the thing, Red Hat, whatever is required. And you are selecting a machine type also. Based on the machine type selection and operating image selection, your machine will be ready without operating system, correct? That's what exactly the things are happening. This particular concept is exactly called as a virtualization. Exactly called as virtualization. Virtualization is nothing but splitting the underlying hardware into different machine types with operating system. That is what exactly the virtualization. Concept is very clear. Okay. What exactly the problems? Now we will see what exactly the problems you are getting with the virtualization. If we just come here, team, for example, if you see this one, there are development teams. Let's consider the development teams. This is Dev Team 1, Dev Team 2, Dev Team 3. Okay. One thing, team, this is one project, another project, one more project. Okay. Each project has individual contributors. That's what they are called as developers. For example, team, the first team 1 is using Java 8 in developing their microservice. Another team is using Java 11 in developing their microservice. Another team is using Java 17. Okay, I'm not stopping that. But the point we need to take a note here is, whenever these team members informing the infrastructure as a Devops engineer, especially this guy is a Devops engineer, okay, infra team, when they inform about the infra, hey infra, we need an environment where we can deploy our applications. Okay, now you know what exactly infra will do. Infra will buy a virtual machine to host their application. That's a common thing. If that is a on-premises, of course they will buy there. If it is a cloud, of course they will provision like however we provision, same thing. Okay, infra install. Okay, first project one guy came, okay, I'm using Java 8. Okay, I will install Java 8. That's okay. Next, Dev team 2, another project guy also came and asked like, hey, I also want to deploy my service. I'm using Java 11. If this guy, whoever the infra, if he override the Java 8 with Java 11 in the same VM I'm talking about, if you override Java 8 with 11, still your things will work. Okay, things will work because team Java 8 with 11, because upper version always supports the lower version, no doubt in that. Upper version, max version always support the min version. Java 11 support Java 8 for sure, but Java 8 will not support Java 11. Point to be remembered. Okay. Third team also came and mentioned to infra, hey, I'm using Java 17. Then again infra guy came and just go there and just mentioned this one as 17 installation. You know what exactly this guy did? This guy is trying to accommodate all your 3 projects in the same virtual machine, because this is a high-end mission. Just assume high-end mission. High-end mission means some 16 core and 64 GB RAM. Such a big mission. Okay, 16 core and 64 GB RAM, for example. It's a very big compute. Okay, it's a very big compute, very costly also. Now he's trying to keep these 3 projects in the same VM. That is what his goal. In this way, if your project teams comes to your infra team, if your infra team provision 8 are overridden by 11, overridden by 17, okay, 17, whatever the projects especially you are deploying inside this particular VM, all 3 projects will work. No doubt in that. These are called standalone deployments. You will package and you will deploy. You will package, you will deploy. You will package, you will deploy. Okay. So this particular project may be listening on 8080, this project will listening on 8081, this project listen on 8082. So that 3 ports you open for 3 different services. That's absolutely alright. Now the problem is, for example, let's consider the same scenario but in different direction. Okay. First Java 17 came and asked infra, hey, I'm using Java 17. Okay, obviously he will be ready with mission Java 17, right? The moment when the Java 11 came and mentioned like, hey, I need Java 11 for sure. Can you please go there and override Java 17 with Java 11? That's what exactly we tested locally also. Then this guy, if we override 17 with 11, this guy will not work. Always the lower versions will not support the upper version. If Java 11 installed, Java 17 project will not work. Java 8 installed, Java 11, Java 17 will not work. Okay. I'm getting a lot of problems, especially if I use the same virtual machine because of the version mismatches. I'm struggling over, infra is struggling over really selecting a virtual machine with the different versions. Now, I'm introducing another technique for the infra. Okay, why I need to worry about these project teams? Let me provision 1111 VM for each team. So dev VM, one low end mission, this project, one low end mission, this project, one low end mission. Now team, number of missions are keep increasing, first and foremost. Number of missions are keep increasing. And secondly, whatever the compute you are dedicated, for example, maybe you just dedicated here 4 core and 16 GB only. But still, you are not in a position to utilize 4 core and 16 GB fully. You are underutilized. Infra provision 3 virtual machines for you, but ultimately or finally, you are seeing virtual machines are underutilized. That's a problem. So, you are not really using your virtual machines effectively. Problem number 1. Problem number 2, always I am getting issues with the versions whatever you are trying to deploy. Okay, that is the problem. Because why you are getting issues? Because all the 3 applications running platform is same. If the running platform is same, obviously you will get issue with versions. Okay, that's a common thing. And second one is your VMs are not 100% utilized, underutilized. And the third one, there is a burden on the infra team always, okay, because you are confusing them, and you know what kind of issues will come all of a sudden. Example, Java 17 installed in this particular vision, later Java 8 you override it, then Java 17 project will not work, then you know you will come and debate with this guy. hey, my project is working locally good. It is not working in your environment. There is a problem with you. Of course, there is a problem, but he cannot solve each and every time, right? I'm just taking some simple 3 projects, okay? But he cannot remember this particular case. That is exactly the problem usually you will get in real-time case system. And especially one more case I will notify you. In, for example, if well-established organizations, in production, especially, what are the physical boxes? We will call VMs as physical boxes. What are the physical boxes they are using? They will use the fixed version. Either across all the boxes Java 8, across all the boxes Java 11. That's it. You also need to think about, you should know that first, and you also simulate your development with the same version. If you simulate your development with a different version, when you go for production, production will not work. You got my point. Production operating system, production or Java versions are standing at Java 8. But you tested your program with Java 17. All of a sudden release day when you move this one to the production, in production Java 17 features will not work. That's exactly the real-time case problem. So these things and all are there, especially when you think about virtualization. That's why we are going for a method called containerization, where the containerization is really helping you to understand more, especially how to deal containerization, how exactly you can pack each application service and you can maintain, how exactly you can pack it, and how exactly you can isolate this particular pack from each other. Repeating again, how exactly you can pack your project and how you can isolate this particular package from each other. That's the point. Let's consider this case, okay? Now, team, if you consider this case, there is an underlying hardware. On top of it, host OS is there. I'm talking about containerization. On top of it, host OS is there. There, you are seeing a thing called hypervisor. Instead of this particular, this particular hypervisor is not exactly the correct word to be used here. I'm just using here container engine, okay? Container engine. So I just need to simulate a case for you. I think this is end-to-end representation. Let me draw the same diagram for you so that you will get an idea, okay? I'm just separating this containerization diagram separately so that you will get an idea. This one I will just explain in a few seconds. Just wait, okay? Just wait. Yeah, alright. I just took this one separately. Just come here, just come here. Okay, let me discuss the containerization here. Okay, containerization here. What exactly this particular thing? Team, if you notice this particular thing, so far, this is what virtualization, correct? Virtualization diagram and this diagram both are same. I don't see any difference. See, both are same. Exactly the same thing. Instead of hypervisor, if you keep container engine, you know what exactly you are trying to do? If you keep the container engine, what exactly the container engine is doing here? See, container engine, especially you need to think about one case, okay? The container engine is responsible to split your operating system into different mission types and operatings, OS. Repeating again, the container engine is responsible to split your host operating system to the guest operating system and individually, and each guest operating system is completely isolated. So you may be little bit confused here. Let me sort it out, okay? I'm just taking out this one, I'm taking out this one, I'm taking out this one also. Now this is very clear, right? This is hardware, on top of it host operating system, on top of it container engine, correct? So far good. Now container engine responsibility, what exactly the container engine is doing? See, whatever you have specially the operating system you have specially in your underlying operating system. That operating system will be splitted for the different types of missions. Those missions are called as containers. Those missions are called as containers, not the virtual machine. Those are called as containers. See, in virtualization world, you are splitting the hardware. In containerized world, you are splitting the operating system. That's exactly the difference here. The virtualization will split the hardware. That is why even when you go for a virtual machines, when you restart your virtual machines, your virtual machine booting will take some time. Always. But here, you're just splitting up the operating system team. You're just splitting up the operating system to different containers. It is very easy. It is very easy to just bring that particular container to be up. That is what exactly I'm just creating C1. Just an example. I'm just creating a C1 and followed by I'm just creating one more C1. Yeah. Alright. So I'm just creating a C1, C2, C3. These are all the different types of containers which you are seeing. Okay, which you are seeing. So I'm just what exactly the point I'm trying to highlight here. C1. C2, right, or something like that. Okay, something like that. I'm just keeping these particular things here. Okay, this is what exactly the thing I'm trying to highlight here. Okay, all right. See, the container engine is splitting your operating system into different machine types. Those are all called as containers. That is what exactly you are doing. Okay, but how this is happening? This one will not happen just like that, team. Okay, again, you need in between you need a virtual machine. Okay, again you need a virtual machine. Then only you can do such kind of things. That is what exactly your virtualization is also part of this one. Okay, for example, I'm just separating this one. In between host OS, I'm simply bringing up another one called hypervisor. This is what your hypervisor, right? This one you know already. So this is what hypervisor. The hypervisor. You know what exactly hypervisor responsibility? Hypervisor responsibility is to just split that particular hardware only. You know that logic already. Okay. I'm just improvising the case here, team. You just bring this one a bit up. Okay. I'm just keeping the containerization this side. I'm just after that hypervisor. You know one case very clearly. The guest OS will be there in the picture, right? I'm just simulating the virtual machine case only. Virtualization case only. So the guest OS will be there. This is the common thing, right? I'm just keeping the guest OS, correct? Guest OS. On top of it, what exactly the thing will be there, team? So guest OS, by using guest OS, a virtual machine will be provisioned. Correct? That's a common thing. I'm just taking one virtual machine. That's not virtualization, right? You just go to the VM section. I'm just taking one virtual machine, team. So this is the virtual machine exactly. I'm just picking up here. You just come here. Whatever the virtualization, this is what the VM. Now what exactly I'm connecting on top of this particular VM? I'm installing container engine. I'm installing the container engine. This is what exactly you should understand. Okay. So you know what exactly you did? See, the virtualization is there. On top of virtualization, the process being changed. So far, you are deploying application directly in the VM. But from now onwards, you will deploy first container engine. On top of it, you deploy your applications as a container. You can run your 3 project applications at 3 different containers. One with Java 8, another with Java 11, another with Java 17 also. That is absolutely possible. The point you should understand here is, see, hypervisor is sitting on your host operating system. Agree? But the container engine is sitting on your guest operating system, where it is splitting your guest operating system to different containers. That is what usually we'll call them as the libraries or binaries. That's what exactly been inherited from your guest operating system. That's exactly the thing, team. Okay, that's a common thing which we will follow. Alright, team. This is what exactly the containerization. This is what exactly the virtualization. So the concepts are same, but on top of it, the containerization came into the picture, and they just come up with an idea. Why don't we isolate all your applications? Why don't we make the deployment separately? That's where the container 1, container 2, container 3 came into the picture. That's perfectly alright. Okay, good. So far good. So that is what exactly which we should understand about the containerization and virtualization. Any questions so far? Alright. Hope you already understand what exactly I discussed now. Okay, that's really good. Okay, alright. So now I'm going to show you a simple thing, you will get some idea, okay? How exactly DevOps model will change when you think about containerization. Standard model. Standard model. This is what exactly virtualization deployments, that's what exactly we did so far. Instead of VM, we used app service and we deployed. Now, if it is a container world, what should we do? CT, let me explain. Azure repository, code check into Azure repository is as usual, no change on that. And also build pipelines will pull the code and it will build it. That also no change. And followed by Azure Container Registry. Okay. What is this container registry? See team, so far, what is your build pipeline output? It's a simple jar file, correct? From here onwards, your build pipeline output is an image. That's the only difference here. Okay, they will pack everything. And they will build an image. Like how you have, while you are provisioning a virtual machine, you selected an image, right? Something like that. Same image will be produced. That image you need to store it somewhere. That's where we are using Azure Container Registry to store that image too. The next Azure release pipeline will pull that image and it will deploy into your app service or Kubernetes. That's all you need to think about. But what exactly the change you are bringing for the virtual machine? Virtual machine so far downloaded with Java and Maven, right? That's right exactly I think we have seen Java and Maven installations in the VM. But on top of it, you need to install Docker Container Engine. Correct, right? You need to install Docker Container Engine. Then only it makes sure it is a containerized environment. See, on top of the guest OS, VM is there. On top of it, you need to install Container Engine. Then only you can launch your containers, you can build your images. That's why you need a Docker Engine. That's all the DevOps model changed in. You understand the DevOps model change? This is what the DevOps model change which we need to think about. That's all. Nothing more than that. The model is same. Only container registry and the Docker engine came in between. That's all. That's all the difference. Rest all same. I don't see any difference as such. Okay. So now our aim here is we need to go there and we should be able to install Docker engine, especially in a Ubuntu machine. That is what our goal now. Okay. First, we should make sure our environment is ready with this. See, our VM, usually we will make sure our agent is ready with installations, right? Similarly, we are going to make sure our agent is ready with Java, Maven, Docker engine. Then only we can run our project, okay? So now we need to install our project, especially our VM with the Docker engine. Then only you can do or you can play with the containers or images. That's the point you need to think about. All right. Thank you for the session. See you in the next part.